Hello, students. Today we are going to talk about centripetal acceleration. You have already read Newton's second law of motion in your O levels and in AS level as well. The most popular saying of Newton's second law of motion is that if an object has to accelerate, then there should be a resultant force in the direction in which the object has to accelerate. So, in circular motion, because this is a topic of circular motion in A-level physics and centripetal acceleration. So in circular motion, the object has to change its direction at all points of the circle during its motion. And it moves around center of the circle. If you look at the diagram, the object is a blue dot or a blue body, and it is going in anti-clockwise direction around O. You already know that in a uniform circular motion, the radius has got to be constant, and the angular speed also has to be constant. You already know that velocity changes its direction in circular motion at each and every point of the motion, whereas the angular speed or the circular speed remains constant in uniform circular motion. At the same time, in order to change the direction of the object at every point of the circle, there got to be a force so that it can produce an acceleration towards the center of the circle. Now, the force that is applied is called centripetal force, and centripetal force causes centripetal acceleration. Before I go ahead, I also want you to recall Newton's first law of motion, that there has to be a force to change state of rest or of uniform motion in a straight line. This force has to be a resultant force. I also want to remind you certain examples of circular motion which are written on this page. There are three of them that I have written. There are so many as you can recall, and from your experience while you go around out of your home or inside your home. The number one example is a stone being hurled around with the help of a string above the head of a person, a vehicle going around a turn. Number three is Earth moving around Sun. Now, the centripetal force for the stone is being provided with the help of a string and being pulled by the person in the center of the circle. Vehicle going around a turn, centripetal force is being provided at the point of contact of the wheels and ground. That is also directed towards the center of the circle. Earth moving around Sun, centripetal force is provided in the form of gravitational attraction of the Sun on Earth. Similarly, in an atom, electrons going around the nucleus in their orbits, there is electrostatic force that is providing centripetal force, and all these centripetal forces are resultant forces. So whenever there is a resultant force, there is an acceleration, and from Newton's second law of motion, you have already read this formula. F is equal to ma, shown below the green lines. If we apply this formula to circular motion, then we can say that Fc is equal to mac, where Fc is centripetal force and ac is centripetal acceleration. Please also remember that AC can be expressed, that is, centripetal acceleration can be expressed in terms of velocity and radius, and that formula is shown in green. AC is equal to V square over R. Now we can introduce angular speed in the above formula. Can you see that Fc is equal to mac and AC is equal to V square over R? So Fc can be written as mv square over R. Now, in our previous lesson, we have read that V is equal to R omega, where omega is circular speed or angular speed. So if we place R omega in terms of, if we replace V square with R omega square, then our centripetal force turns out to be equal to mr omega square. So these two formulae, that is Fc is equal to mr omega square and AC is equal to r omega square, are the formulae that we have learned in the topic of centripetal acceleration. Please also remember that whenever you hear the word centripetal, your mind must tell you that it is something to connect with circular motion and direct it towards the center of the motion. Thank you. Now we are going to do a very simple question on circular motion. I have taken this question from the A-level physics book, and it is a question which reads, the minute hand of a large clock is 3 meters long. What is its mean angular speed? To solve this question, I would recommend that whenever you want to solve a numerical, you must note down the available information, which is also called the data. Also, the formula that would be used in the solution must immediately jump into your mind. So, if I have to note down the data, it is number one, it's a minute hand of a clock, so its period will be 60 minutes, which is also equal to 3600 seconds. You must remember that the units to be used in solution of any numerical are to be standard units that are there in the physics syllabus. Number two is length of the hand, and that is 3 meters, or radius is 3 meters. Requirement is that we have to find out the angular speed, and symbol for angular speed is omega, and the formula is omega is equal to theta over t, which is also equal to 2 pi over t. Here, since we have capital T in the available information, so theta will be equal to 2 pi radians. We put in the information in the formula and then use a calculator, and the answer would be 1.75 radians per second, rounded to three significant figure. This is also an answer in standard form. And remember, you have to give answers in standard form. More practice of this concept are coming up next. Thank you.